Hey folks, I just want to give an example today of some thinking that goes on as we're filling in the stage 1 on the backwards unit design. So I have up here my backwards unit design for the atom unit, and you can see right away this is last year's document. And I just brought that one because people have said, well, do I have to cut and paste everything into the new one? Nope, you don't. This will certainly work too. Our new one doesn't have the scary titan staring at us, and you'll see one other big change as you look at it. And it's this, that the final piece right here, that is not in stage 1, that's been moved down to stage 2. The reason that that has happened is because that's what the original document looked like. And the thought was, well, we really want to think about assessment right away, right after we do the goals. These two seem to kind of go together. Here's what I'm doing. Now let's make sure I'm actually testing it. But when we move that up, then a new box called the critical task box was put in that place back in stage 2, and that was very confusing because there was no common language or common definition. And so after trying it for a year, we decided to go back to the original design, which means that this is in stage 2, not up here. But I'm not going to recreate this at this time because it works just fine for me. So it's fine to use last year's document. All right, so now when I look at this, let's start off with this top box. What goes in here? What goes in here? In chemistry, we have Michigan content expectations. There are numerous. There's about 150 of them. There's no way we could possibly get all of that done in the trimester, or if we were even back with semesters, we would not have gotten all those done. So what we've done, and what you have to do as well, is to look through those and decide which ones do you actually teach, which ones are the ones you're going to attend to. So in chemistry, again, we are turning to the Michigan content standards, and from those we created what we call our power standards, a subset of what the state says. I know in world language you use the ACTFL standards. I know in math you use the Common Core, and other departments have had conversations about what is most appropriate to go here. Now, when you look at this language that I've got really is not in any sort of education speak. It doesn't look like content standards. I can go back and pull the Michigan core content and tell you this is 6.2a, or I can just take that language and turn it into language that's more comfortable for me. It really doesn't matter that it's coded. It just matters that you use a common source document that makes sense. So then after the goals box, what I tend to do is I tend to fill in the knowledge and skills box, which isn't on my screen. They're way down here. And I don't even feel like I need to have that on the screen because you know what goes in the knowledge and skills box. That's easy to fill in. This we usually have no problem. I can tell you what kids will know, and I can tell you what they should be able to do. So that's where you just list those things. The boxes that are more interesting for us are these essential question and understandings boxes. These tend to be the ones that are harder for us to fill in because that's not what we've been formally trained to do when we were back in school in the day. We were trained to list what students should know and be able to do, knowledge and skills. Okay, so I'm going to start with the essential questions box. And I left this one kind of in its draft form. In my essential questions box, I've got one that's highlighted, and I've got 3 that kind of were brainstormed. In reality, my updated document has the highlighted one, which I highlighted to remind me this actually came from working with Mr. Hofstra. He suggested that we change or add this one, and it made perfect sense. So that one came as a result of collaborating. Then these next 3 were kind of brainstorm stage here, and those have been changed into kind of 1. And then I actually this year realized that I had another one, and it was all about how scientists use special notation for communicating clearly. So I have 3 essential questions. Can atoms change? If so, how? What happens? And then I have these 3 that I've combined into how does the knowledge, how did the knowledge of atoms change human history? And then the last one I have is how do chemists communicate clearly using special notation? So these are big questions that they can answer throughout the unit. And as you can see, they are not static. I have changed them from year to year, and I've actually added them as I go through the unit, and that's perfectly fine. But they're questions that students can return to as they are working through the unit. The last box is the understanding box, and in the understanding box, the line that keeps popping up is that these are bigger things that must be uncovered. Just do a little erase in there for you. Often there is a pretty good correlation between the understandings and the essential questions. So for example, this big understanding relates quite well with my first essential question. This understanding relates with this essential question. And this one here that talks about symbols related with my third essential question. So often there is a one-to-one correspondence. It need not be one-to-one though. Often people ask how many essential questions do I have to have, and the guideline is 2 to 5 in a unit, or as the great Dan Rosenberg says, you just cook it till it's done. The understanding box, though, are things that are to be uncovered. They are more complicated. A superficial understanding of the material will not suffice to get to the understandings. So, for example, my first one, it's pretty obvious to kids that atoms are made of smaller parts of protons, neutrons, and electrons. What isn't obvious to them is that those are made up of smaller parts, which is what people are currently studying, and that when these parts change, number of protons changes, or the number of electrons changes, then that's when we get chemical change or nuclear change. And so that's a much bigger concept that takes them a while to understand. It has to be uncovered, in other words. This idea of communicating clearly, also, I could give them a key and just teach them how to write things out in chemistry. But the bigger idea is that there are different ways to represent a model, and communication is done to efficiently communicate. That lesson I'm not really happy with, but oh well. Anyways, I hope that this kind of helps you get some ideas of the thinking that goes on as we fill these in. And in chemistry, as I was indicating, we've done some collaboration. The best way that we've seen so far to collaborate is by having a common Moodle page for teachers, not that the students see, just for teachers. And we can load these up and pull them and talk about them as needed. So anyways, I hope that helps, and good luck writing your unit plans.